Okay, here in 5.5 we want to be solving polynomial equations. Okay, so we've talked a lot about their graphs and what they might look like, but now we're going to be solving the equations. And we're going to do this first of all today by factoring. So we've done a lot of factoring already, and a lot of that is going to come back to us in this section, and we're going to of course extend it a little bit so that we can do some of these higher order things. The first new thing I want to show you is what we would call a special. Okay, it's special and should remind you of a difference of squares, but this time we have the sum or difference of cubes. So let's take a look at what this looks like, and the words should make sense. So let's start with the sum of cubes. So for example, I could just have a cubed plus b cubed. And there is a way to factor this, and I'm going to give it to you the first time, and in class we're going to actually go ahead and derive this ourselves. So how would we factor this? The rule is you have to have your cubes here, so we have to know what's being cubed. A is being cubed, and then b is being cubed as well. So the first factor is just a plus b with no exponents anymore. Okay? Then what happens is you have the second factor. There will only be two factors. This first one only has the two terms, and the second one will have three terms, where I square a, and then I subtract ab, and then I'm going to add b squared. Alright, so this is something that you're going to memorize, or you can derive it every darn time you want to, but I suggest you memorize it. And in order to help you memorize it, I'm going to show you what makes it very similar to the difference of cubes. So let me do both of these, and we'll talk about their differences. This time I have a difference of cubes. So this time it's going to be a minus b is the first factor. Okay, so you'll notice whatever the sign here is the same as the sign here. Okay? So those are the same sign. Then this is going to follow very much the same pattern, except we're going to change a sign. Still a squared. This time it's plus ab, and it's still plus b squared. Alright, so how do you remember this? This is always plus. This one always matches. It always matches the original, that sign. And you'll notice this sign is always an opposite from the first sign you did. Okay? So that's the way you're going to remember it. And that should be committed to memory. I'll remind you that there is one other special that we have that we used to do, a squared minus b squared. And that one could be factored as a minus b, a plus b. Just as a reminder, I'm going to remind you, a squared plus b squared does not factor. So in the case of squares, you can only do the difference, but in the case of sums, it's very special. You can do both. Okay, so here's a question we could do. I want you to factor x cubed plus 8. And remember, I told you that you had to identify what is being cubed. So, because you don't have a little 3 exponent above the 8, right? So we want to make sure it does have a little 3 exponent, so we have to rewrite this. X cubed plus 2 cubed. So that's what I mean by identifying what's being cubed. Now the x is taking the place of a, and the 2 is taking the place of b, and I can go ahead and factor this. Hi! Okay, so let's see if we can finish factoring this now by the formula that we learned. And that was, if you remember, x plus 2 without any exponents at all, first factor. Second factor is going to have 3 parts to it. When you square them both, so 2 squared will be 4 here, and then you take 1 of each in the middle. 2x goes in the middle, 1 of each. And then, what about the sign? This sign had to match, right? But then this sign is always an opposite. So match, then opposite, and that comes with your answer as the factors. Okay, I want you to try this next one. It's 27x cubed minus 1. And I'll just reiterate, you need to identify what is being cubed in that first term, and in the second term, of course, too. So go ahead, I'm going to pause it, and you're going to pause it. We'll check our answers. Okay, you see what I came up with as an answer? Because 3x is the number that's being cubed, so I just repeat everything without the exponents, and I square the first one, I square the last one, or the second one, and then I take 1 from each, right? A 3x and a 1. Multiply those together and get 3x. This sign stayed the same, it matched, and then this sign, of course, was the opposite. This one is always positive here at the end. So that's the way I remember it. Alright, so I'm going to remind you, the next thing we're going to do, we're going to just be able to do all the types of different factoring that we know how to do now, including grouping, in order to solve these big polynomial equations. So let's try a big one. Okay, so I'll remind you that this one is one of those quadratic type equations, okay? It's quadratic type because it has a middle term that is the square root variable. The variable, anyways, is the square root of the first term's variable. Okay, so these two match up, and then there's, you know, a constant term after that. So that makes it a quadratic type, and I'm going to treat it like a quadratic. So when I start to factor this, I have something x squared and something x squared. Now I'm going to have to factor this. I know I have 3 and 1 for the last numbers. It's going to be minus and minus, so I can make a plus 3 at the end, and that will give me minus a number in the middle if I have something minus. So I have to make the 18 first. I'm going to go with 18. Oh, who caught it? I know I missed it, because I can see what's happening now. I forgot to do the GCF first. So let me start over. GCF comes out. There's a 3 common to everything. 6x to the 4th minus 7x squared. I know, you're all screaming at me. You all caught it well before I did. I don't need that 3 anymore, so cross it out. Divide both sides by 3. So now let's set up my quadratic type equation. I know I have 1 and 1 this time. That has to be minus and minus. It's going to be x squared, and x squared is my variables. And how do I make a 6 so that in the middle I have a 7? Obviously 6 and 1. So that gives me minus 6 and then a minus 1. So I get 9 is 7x squared. So I have successfully factored this. Now I can factor this further, what we call over the integers. So not allowing any fractions or certainly no irrationals. But I can factor this as x plus 1 and x minus 1. That's one of those special difference of squares. And that's as far as I want to factor, so I'm going to go ahead and use my zero product property. Everywhere you have factors, you have multiplication, you divide this up into its own equation. 6x squared minus 1 equals 0, x plus 1 equals 0, and x minus 1 is equal to 0. So we're just taking that zero product property, but now we have more than 2 factors like we did with quadratics. So any number of factors here. And then I'm going to solve each one of these. This one I'm going to choose to extract square root. So 6x squared is equal to 1. X squared is 1 over 6. X is equal to plus or minus the square root of 1 over 6. But of course I have to rationalize that. X is equal to plus or minus the square root of 6 over 6. And in the middle, x is equal to negative 1, and x is equal to plus 1 for this last one. So there are my 4 solutions. And that makes sense because I did have an x to the 4th, so I would expect to get 4 solutions. Okay, we're just going to take this opportunity to do a little more practice factoring. So we're not actually solving these polynomial equations right now because we want to work with polynomials of 2 variables. So we won't be solving these, but we'll just be factoring this type. And we haven't done a lot of grouping, so we'll try and do that first. And let's do a great big one here. Hold on, let me write it out. Okay, so here's a monster polynomial. You've been asked to factor this, so the directions would just be factor this. And you look at this and say, wow, there's a lot of terms here. 1, 2, 3, 4, 5, 6 terms in this. So I'm not going to be doing any kind of unfoiling or quadratic type or anything like that. I can look for a GCF, not an X and everything, not a Y and everything, and there's not a Z and everything, so, and there's no numbers and everything. So, okay, no GCF. So with this number of terms, really the only option you have is factor by grouping. So let's look at a group and decide how to do this. I start to see patterns at this. I see a 1, -3, 2, 1, -3, 2. What's different about them is the y cubes or the z cubed. So what if I factored out the y cubed first? X squared minus 3x plus 2. And then let me factor out the z cubed from all the remaining terms. X squared minus 3x. Oh, look at that. Those are coming out to be the same. So when that happens, factor out this from this. That's what I'm factoring out front, so I have to leave a parentheses for what's been left behind, y cubed plus z cubed. But there I'm not going to stop because each one of these can be further factored. The x's. Okay, that makes the first factor into 2 factors, and then this second factor here is a sum of cubes, which we just learned how to do, y plus z, without the exponents, and then y squared plus y. Nope, that should be a minus, because that one has to be, that's a minus. Minus yz plus z squared. And that would be my fully factored form. You could try all you want to factor that further, but in general, that piece of factoring when you're doing the difference or sum of cubes is not factorable, okay? So in the future, we're going to have other methods for dealing with that and solving when we have that. But that's factor by grouping. Again, just even a little more terms than we had before, maybe 4, now we're up to 6 because we're going to continue factoring. Alright, so here's 2 problems I want you to do for homework. I want you to factor these 2 problems, okay? And then try solving this last one, which will be a quadratic type. The hint I'll give you here, I'll give you a hint. This is a difference of cubes. And then there might be more to do after that piece of it, but start with difference of cubes. And we'll go over these in class and see what you got.